coming from this topic. So what is that? The story starts from string token. Okay. Now, although today I cannot find any bug from string token. Okay. But if you remember this, okay, string token, you call it first with the string as an input. Then for next call, and I mean not next, but the subsequent call, you don't need to put down the string again, as if it is memorized, right? The string token. So my illustration is like this. Any jobs? No. Okay. Yeah, jobs is a real command. Okay, don't think there's a command for your shell. Normal string token, okay, it is to break Linux is a cool operating system, this statement into pieces, okay. So the normal string token is like this, yeah, the main and do things like that. I use a do while loop, okay. The first call with the buffer, the subsequent call without the buffer. And my delimiter is space. Okay, this is normal, and you know how to write it. You know how to write it. How about preferred version? Okay, because this is the preferred version, I have to input two different strings. Okay, so I declare. I use a define. I declare two threads. I declare two threads, and these two threads, okay, I created using sprintf. Sprintf means make some pattern into the string, and the string pattern is by the end of the string I will output the ID here. Okay, this will become thread 0 says Linux is a cool operating system 0. String 1 says Linux is a cool operating system 1. So I don't need to back up because I already create two variables, separate variables for two threads, and pass this as the input. So the previous problem are all gone. Okay? To illustrate this example, I also input one thing. I change a bit inside this loop. Okay, inside this loop I change a bit. Before I go through the iteration, I add slip 1. Okay, I add slip 1 so that you can see the change bit by bit. Now it means I create two threads with two different inputs. Go. Is it what you were expecting? What you're expecting is something like a thread 0 and then say thread 1. Right? It's thread 0 and then thread 1. And because there are two threads running with two different inputs, so say one containing how many tokens there? Let me check how many tokens. 6 tokens, right, in this string. Okay? At least you will find 12 different lines appear with repeating tokens, right? But you cannot find repeating tokens, right? You find it so strange. It becomes saying that thread 1 says Linux is a cool operating system 1, as if this input dominates both threads. So, why is that? This problem is called thread safety. So what does this thread safety means? It means there are some bad calls, bad library calls. How many bad library calls there? String token, random. Random is also a bad call. And this kind of bad call is actually doing something like this. When you call it, it saves something using malloc. It saves something using global variable. Okay? It needs this because it have to memorize your string, right? You call the string token for the first time, you need the input string. For the second time, you don't need it. Why? Of course, it's being safe, right? It's hiding something inside the function. And say, input string from fat1 is being saved. Okay, so this is step number 1. Being saved inside the string token function. And the delimiter, you need a delimiter, right? Delimiter is one space. So you upload it, yes, upload into the function body, and also upload the current position that you are processing, because you need to point where is the last stop, okay? Then what happened? What is happening is when fat2 is being created. Fat2 is being created, when fat2 uploads their data, you only have one slot, okay? You only have one set of string token call. When you upload for another time, all previous string will be erased, okay? You have one slot only. I upload something from fat1, and I also upload another set of things from fat2, you only have one slot. So all gone, okay? And fat1 being cheated, it don't know the internals have changed, all the things being changed by this guy. It will keep on calling it as if nothing happened, okay? So it will have such kind of interesting thing, okay? And it's called thread safety. How to make an unsafe call more, not more, but become safe. Please invent one thing. Store all the things that previously that will be saved inside the string token structure. Move it back to the local variable. How to move it back to local variable? Yeah. Prefix. Oh, not bad. String token underscore R. There is another call called prefix underscore R. I will use it in another example. And what is this? Now let's check. Man string token. Okay? You never ask, right? You never ask your tutor, you never ask the man page, because you seldom read man page. And our tutor never tell you there is another version of string token. Okay? One string token is the one that you keep on using. Another version is similar. The first argument pair, they match. Second pair, match. Third, what is that? That is the saving point, okay? As if this is a, maybe this is a 2.0 example, okay? You have a memory state to your PSP, okay? This is the memory state. You plug in it, okay? Plug in the core, you provide a space to save all the data required by this guy. Originally, it saved all the data inside the function, maybe through malloc or maybe through global variable. Now, sorry, I don't use this way. I will move every data, okay, to the caller. The caller give me the buffer. You give me a buffer, I will save all the data for you, okay? Now go back to my code. I have a place called save pointer. Okay, I create this special data structure, not special at all, it's just a char pointer. I create a char pointer so as if create a buffer place for me to save all things that the string token will use. Okay, so this is called reentrant property. Allow you to re-enter the function without any error. Reentrant property. Okay, there is many codes, many library calls is fat and safe. Okay, many calls are fat and safe, but don't be afraid that many code that you're using is fat safe. First of all, malloc is fat safe. Okay, although malloc you can call from one thread and another thread, okay, it's guaranteed to be safe. It doesn't mean that in one thread I call malloc 10, another calling malloc 20, okay, you will lose 10 bytes or 20 bytes. No, it's very safe, okay? So it becomes something like this. I create a space, storing all this batch of things into here, okay? So I think that's it. I cannot dig deeper. If I continue to dig deeper, actually you need to buy a book, okay, to understand all the prefix properties. But prefix properties give you more trouble, but give you a high degree of concurrency. Those troubles are exclusion, synchronization. Yeah, these two you already face that. One more extra thing, fast safety. Okay, so I guess you have a very tired night. So hope you enjoy the journey here. We will already start another journey over the file system, and on Monday you will continue all the file system thing. Okay, so thank you very much. Pause.